Double displacement reactions that produces water. A typical reaction includes neutralization of an acid and a base. We've looked at this previously before, right? Combine an acid, right? Hydrogens, base, hydroxides. Those are some of our hints. They're going to form a salt and a water, right? So, sulfuric acid plus sodium hydroxide produces sodium sulfate, which is our salt, plus our water. Right? So that's one type of neutralization reaction. And then there are a few that don't look as obvious. Most metal oxides, so think of it this way, any metal oxide are considered bases. Remember what were bases before? The hydroxide. Right? So now we're going to identify the fact that we can have a metal combined with oxygen and it's considered a base. So when we see a metal oxide combined with an acid, right, similar neutralization reaction will occur. Right? So here's our acid, okay, nitric acid, combined with magnesium oxide. So that's going to react to form magnesium nitrate plus water. We're still forming our salt and our water. We have our acid. So if you see the acid, you see water in your process. So you're looking for acid in the reactants. You find we've got a water and an ionic compound in our products. Look for the fact that we have our metal oxide. Any type of metal oxide. So it's not necessarily that we have to have the hydroxide, as we've seen. So this is now a new exception to the neutralization rule. Another one is most non-metal oxides. Right? Remember, if you go back to your types of reactions, right? So go back to the lesson on types of reactions. Look for the reaction that involves the formation of acids and bases. And we deal with this concept. The metal oxides and the non-metal oxides. So go back to that if you have to. And you'll see exactly what we're talking about. So now, non-metal oxides are acidic, and obviously if they're acidic, if they react with a base, okay, they will form a neutralization reaction as such. So here's one. Carbon dioxide gas, considered acidic, combines with lithium hydroxide, which is our base. We're forming water, and here is our salt. So remember what we said? Look for either an acid or a base that are obvious to identify. Then look for water in your product. Then also look for the fact that you have an ionic compound. Odds are these will represent either an acid or a base. So they're not all cut and dry like we've been taught before. So there are a few exceptions to the rule.